Welcome. In this video I'm going to show you how you can perform a one sample trimmed mean test, also referred to as a Yuen or Yuen-Welch test. Usually it's done for independent samples, but can also be used for one sample. I'm going to be showing you how this can be done with R and my stikpetR library. I'm using R version 4.3 with the basic packages that come with R pre-installed. I'm using Jupyter Lab, but the R code should also work in, for example, RStudio. Now, this test is similar like a student t-test, but instead of looking at the regular mean, it actually looks at the trimmed mean and uses the winsorized variance. I've also come across two different variations on how to calculate the standard errors, so that will give two slightly different results. To show you how this can be done, I need some example data, so I'll load the general social survey data from 2012, which I've adjusted every now and again for some example purposes. I don't need actually all the data, I just need one numeric field, so I'm going to be using the age field for that, which looked like a good candidate. There were some missing values, so I removed those, and there was actually a category 89 or older, so I replaced those with 89. Perhaps I should change it to something else, but it's just for an example, and make sure everything is numeric, so I truly have a scale field that has numbers only. I'm going to be using as a hypothesized mean 50, so that's the mean according to the null hypothesis. And the next thing I will need is, of course, that library. This library unfortunately is not available on CRAN, so you will need to actually install it first using DevTools, and then link to my GitHub account as shown here. Now, I've of course done that myself already. Once that's done once, I can always load it just like any other library. The function of interest is ts trimmed mean os, ts short for test, and then we have as input parameters the data, of course, and the hypothesized mean, mu. If you don't specify it, it will actually use the mid-range, so the maximum plus minimum divided by 2. You can set the trim proportion, which will be the amount to trim in total. So if, for example, the default of 0.1 indicating to trim 10%, which means 5% from each side. Then, because there are two variations, there is an SE, standard error, parameter, which you can either set to UN, which is the default, or Wilcox. Now we can simply plug those in, and without much further ado, it should give me, I didn't give the hypothesized mean. Let's actually run that one, and hopefully now this error disappears, and I get a nice data frame with some information. The trimmed mean is the first column, then the hypothesized mean, the standard error, the test statistic, which is actually a t-value, the degrees of freedom, which is the number of scores used in the trimmed mean calculation, -1, and probably the most important one, the p-value. If this value is below 0.05, we would usually reject the null hypothesis. So in this case, that assumption that the average age is 50. So that gets rejected in this case because the p-value is below the usual threshold of 0.05, and would claim there's a significant difference. If I would have set SE to Wilcox, we would have gotten the other result. So as you might notice, it's still quite close, extremely low, still significantly different from the 50, but the standard error is now slightly different. In a separate video, I'll show you how you can do it without my own library by using DevTools, paired data, or the hard way by going over all the formulas. Alright, I hope this video was helpful, and thank you for watching.